do think so. Do we have some sound? I'm not sure. Hello, hello. I do think so. Yes, we have some sound. Then let me pop out the chat. Hello, little chat. Hello, hello. Ba, 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 ba. Goody goods. Hello, ladies and gentlemen. Most likely no one is here yet, but we are at day 4. Let me check. We are at day 4, actually. So we worked already 3 days on this project currently. So a day is usually 2 to 3 hours. It's not more than that. And I did a little bit of cheating because yesterday, after the stream, I did some little extra exercise, which I want to show you quickly, because I wanted to check the idea that I had with that we can maybe get an ellipse shape with a polygon interpolation, or how would you say that? So that we use a polygon to somehow simulate an ellipse. And that was my idea. And I thought it's not that difficult. And what I did in the end was what every programmer does in our modern time. I went to Google Gemini, the AI, and can I still see the history of my chats? Yes, I think that one here. So I ask it, hey ho, little AI, do you know how to create a polygon out of an ellipse and give me Java codes? I have the position, width, height of the ellipses, and I want about 20 vertices to represent the ellipse. Then it gave me that piece of code, which I copy-pasted. No, I didn't really copy-paste it because I didn't want to have a function like that. But I did something very similar like that. I adjusted it a little bit because the rounding here did not make sense to me. Maybe something else, I'm not 100% sure. But in the end, it was very simple. And the approach is also actually quite simple. I will explain that in a moment. And there was a problem that I then faced. And there we go now really to the code. Because of you. So the problem was when we have a fixture definition, there is a shape which is called a polygon shape. Yes. And this one, for whatever reason, only supports up to 8 vertices. So if we use more than 8, like in my case, I use 20, then we get an exception or an error with the GNDI integration, and something like count must be greater equal 3 and less than equal 8. So polygon shape did not work. I also asked here if it knows about that, and it says something, yes, it knows about it. But here I wasn't sure if it's hallucinating or not, because sometimes AIs just say that they know something, but they don't really know. But in the end, the solution was rather simple. Instead of a polygon shape, there is also a chain shape, which I anyway wanted to use at some point. And there I can call the create loop function to, when we go a line of vertices, let's say 8 or so, and then we go back, the back way would be this loop, so that it goes from the final vertices to the first one, that it creates a loop. That's the create loop. The other one would be the create chain or something like that. Did I use that as well? Create chain? Yes, I used that as well. So that would be the other one where it doesn't connect the last vertices with the first one, vertex with the first one. And that's it. I also cleaned up this utility here a little bit. So I think it's a lot easier to read now, extracted certain things. So this fixture definition of function that we have, it now supports everything that I could produce in tiles. So we have rectangle, we have ellipses, we have a polygon shape, and a polyline. What is the difference between polygon and polyline? When we select this one here and zoom in, so I tried out a couple of different shapes. As you can see here, so that's the circle and the rectangle that we had initially. Then here I was drawing an ellipse. Here I had a polygon with, I think, 3 vertex vertices, and here a polygon with, I think, 4 if I'm not mistaken. And that one here, so just 2 of them which are not connected, that's a polyline object in LibGDX. And all of these shapes, they have now a separate function. So the rectangle we already know, but here I changed something. Instead of having the polygon shape with the set as box, I also use now a chain shape with the loop. As I explained, I use that for avoiding the ghost vertex problem. Also made here a little bit of a comment that the box is not centered around the position, so that we are doing it a little bit differently. But rectangle, that one is already known. Then the ellipse, that one got enhanced. So here, so if width and height is very similar to each other, then we just create a circle shape out of it, like we did it yesterday. And the other thing, so if they are not equal with this little tolerance that I use here, then we use this code that I showed before. And the number of vertices currently is 20. And then it creates a loop, so a chain shape with a loop with those 20 different vertices. And this one I will explain in a moment how it works, because it's actually quite simple and reminded me of 2D movement, the 2D movement formula that you could use if you don't use, for example, a physics engine. And finally, polygon and polyline. So as you can see here, they are very, very similar. It's the same shape in the background of fixture definition. The only difference is that the polyline, which is this one, that one does not use the loop, so it does not connect the last vertex with the first one. And if we have a polygon, then it is using the loop. And the function for that is also quite simple. So we can get the vertices from the polyline object or the polygon object from tiled, and that one we simply need to scale by the unit scale, and that's it. And then we just pass it to the loop and the chain. And yeah, I think that's it. So that's working also when I started, so that you see it. So all these shapes and fixture definitions and all of that get correctly parsed from what I can see. So that little fixture mess of a player that we see here, this is exactly what we have, or I hope it is exactly what we have here in the tiled collision editor. So now we are officially supporting really everything that we could draw here. And we also have the freedom now. So now I could really make the 2 ellipses that I had initially in mind and do some other things. But for now, I just leave it like that, because I also most likely want to write a test for that it parses everything correctly. But yeah, that looks good. One thing that you might be interested in is this polygon. So they create the polygon out of the ellipse information that we have. So this AI code here. So what the hell is this one here doing? And it's rather simple. So first of all, we say the amount of vertices that we want to have. So let me open Paint to maybe demonstrate it a little bit. So imagine we have here a circle or this ellipse, and we cannot simply create an ellipse like that. Instead, we have something else, which I explained yesterday a little bit. We will have in total 20 different vertex. So we have one. Can I make it a little bit bigger? No, I don't know how. So we have one here, one here, one here. That's 3, 4, then 5, and so on. So it goes around the entire ellipses. So we have in total 20 points. So a vertex is nothing else than a point. So it's an x and y coordinate. And then they are simply getting connected to each other. And obviously, the more vertices we would use, the closer it will look like a real ellipse. If we use, for example, just 4 vertices, then it would look something like this. So it will go here, then here, then here, and then it goes back. And how does that work? So what it does is simply, what is the, how to say that? So the entire circle, what is the length of that one here? So in German, it's Umfang. I don't know what the English word for that is. But the total area here, or not the area, so the length of that circle is always 2 2p. So 1p is half of a circle, and 2p is the entire one. That's 360 degrees, let's say. And we actually then split that up. So we divide those 360, or this 2 times p, divided by the amount of vertex that we want to have. And that is what we have here. And this is now the how many steps we go from the circle. So let's imagine we would go from the right, which would be the degree 0, and 360 divided by 20 is something, I don't know, let's say 10. So an angle step of 10 would be that the next vertex is here, then 20, then we would be here, then 30, 40, and so on. So this angle step decides how far we go here from the direction to find out where our next vertex is. And then finally, it's very similar. So it's also in the 2D movement stuff. So when you are located here and you want to move a player in a specific direction, then the formula for that is that you have x, so the current x position of your player, plus the speed where he should go, multiplied with the cosine of the direction, so the angle where you want to go, for example, 0. And for the y coordinate, it's the same, but instead of the cosine, you use the sine value for it. So if we go to an angle of 0, then we would go like here. So cosine here is 1, and the sine value is 0. But if you would go up, for example, like this one, then the cosine value is 0. We don't move to the right or left, and the sine value is 1, so we go upwards here. And with that little trick, so that's here. So with this angle step, so the amount of angle that we move in our circle, and with this cosine and sine multiplication, we then get the different vertices along our ellipse shape, and we can then create, in that case, a chain shape out of it and create this effect. So that was really, it's not a lot of code, and it was quite easy then to implement. And I was motivated to then simply support all the different shapes which are available in Tiled. And yeah, if you are interested in that, it's the file B2D utilities or B2D utils currently, this fixture definition, a fixture def of function. And there you can see how that translates. Good. Yeah, and also one thing, maybe you noticed that I renamed the tile set. So that one was called Terrain Extruded, and now I simply renamed it to Terrain. So how did that work? I had to do a couple of things, but I simply searched for Terrain Extruded in all my different files. And in the end, oh, it's interesting that here it's still referenced. Maybe here I did not clean it up. Maybe that's even a mistake. So yeah, basically I did that. So I searched everywhere for that string, and then I replaced it with just Terrain like that. So I'm pretty sure that I would need to fix it here as well, because I didn't find a way to rename it inside Tiled. So not sure how that would work. And hopefully I did not break anything now. No, still seems to be good. I saw somewhere in the internet that someone mentioned you click on the tile set and then here you can change the name, but that did not work for me. Good, and with that we actually already did one of the things that we want to do today, which is replace the boxes of our ground with the chain shape stuff. The next thing that we want to do now is to render our player graphic. And how do we go about that? So we need to go to our assets folder. And by the way, we forgot something that we maybe want to do on day 4, because we never considered animations. So we won't have a run, jumping or falling animation or whatever. We never considered that in our plan so far. So at one point we need to do that. And I think it might make sense when we do that after we have finalized the movement of the player, that then on the next day when we work on that, that when we move them to the right and left, that we also see a move animation of the player. I think that makes total sense. For today, we make it rather simple. It's just one single sprite, so there will be no animation. And as a starting point to set up everything for the future, we have our object folder from last time. We have here the frog, and we have here the idle animation, let's say, or the idle frames. And everything else for now, we don't need it. But what we need is we need to open our texture packer. How is it called? GDX texture packer. Because again, we want to combine all the different game objects textures into one bigger texture to avoid then again the texture bindings and so on, and to optimize our rendering process. So what am I choosing here? So I want to create an atlas, which we call game. Let's just write it together, game objects. Then the output directory will be our assets folder, assets, and then graphics. Okay. And what is our input folder? Input folder would be our raw assets from here. And there the object folder. And I think we also need to set here a property which is called recursive. If check the directory containing all subdirectories are packed as if they were in the same directory. Yeah, so we want to do that one here. And now also the padding, let's do it again, set it to 4. I think that's always a good value that I choose. And yeah, let's see. So we get something out of it. There is, of course, a lot of garbage in here. It's not really garbage, but it's not prepared correctly. So it's the entire sprite sheet that we had here in the background. So this one here is one texture with six frames. And we want to have that, of course, as separate frames when we deal with our own animations. But for now, we can just live with that. The only thing that I'm interested in is this one here. The idle animation. Because it looks like it has too many names for the key. So I see here frog idle and then another idle, which is easy to fix. So we simply need to extract those images out there, and then we can remove the idle folder, and then let's repack it. And now it should be named correctly. Yes, so now we have a frog idle. So this is how we can access this texture region inside the atlas, and the yellow number at the end. So here it's 3, here it's 9, here it's 1. That's the index. And with that little trick, so to have these regions separately with this index, we can then later on very easy create an animation out of it. I just want to check for one certain thing, because if I remember correctly, there is one setting here which removes a graphic if it's pixel by pixel exactly the same graphic. And we have that in the idle animation. So we saw that sometimes 2 or 3 frames are exactly the same. And I don't want to remove those images. They should still be part of that. And I remember for sure that there is a setting for that. But is it the use indices? If false, image names are used without stripping. No, it's not this one. If checked, texture packer won't add regions for completely blank images. No. If checked, 2 images that are pixel for pixel the same will only be packed once. Okay, so use aliases. This is the one that we want to untick. That's now better. And what else? If checked, explicit copied into the padding. Yeah, let's also make this duplicate padding again, which might help with some bleeding. And I think That's it. So that's already good enough. So now we need to prepare something a little bit. So we have here the frog, which is the ID from our, so somehow we want to link our game object enum, where we called it here player. Maybe I should call it frog. Not sure. Let's stick it for now with player, but that should be always the first part of the graphic. And the second part would be then the kind of animation that we want to play. So for example, game object is frog and animation is idle. So if that's the state of our entity, then we want to have the idle animation, and we can get it then out of this atlas with game object / idle. That would be the idea. Is that the easiest way to do it? I would say so. At least that's the approach with which we roll for now. So what we for sure need is a class, which is called, let's call it Sprite or graphic, maybe a graphic component. I think that's better. Have you looked at my Compose project yet? Look at it, please, please. Maybe later you can send it to me. Is it, by the way, I saw a video yesterday, I think it got recommended to me. Is Compose only used for mobile phone user interfaces? I thought it's a multi-platform user interface thingy. But again, I don't have any experience with it. I just saw it and read about it from time to time. Okay, so this one should be a component, which we call graphic. Then we want to import it. Can I somehow, with this live template, always make sure that it imports those two things? Maybe that's possible. And anyway, we need here a sprite, which should get passed to our graphic component. So we could initialize it here with an empty sprite and then later on set the correct graphic, which would be totally fine, but I want to have it like this so that we pass in here already the correct sprite. You should stop watching videos. So little history. What? Okay, then let's go to our spawn system. Here we have somewhere the game object entities, exactly. And here we create them with currently just a physics component. And here also we want to have a graphic component where we pass in the sprite. And the sprite, how do we get it? So do we have access to the assets in here in the spawn system? No. But we would need that because we would need to get the texture region out of the atlas. And I'm thinking into the future, we also want to create later on not just the sprite itself, but most likely also the animation. Yeah. Yeah, but let's fix that or improve that later on when we come to that point. So I don't want to think too much into the future. But for now, for sure, what we need is the assets that we inject. We have that available. And we now want to get our sprite out of it. So let's call this function sprite. And what we pass in here, we want to pass in the game object ID that we have available, and maybe also the kind of animation that we want to have, or the first frame of that animation, which would be idle in that case. Okay, so we have the object ID. Then we have the, how we call that, animation type, and we return a sprite. So from our assets, we would like to get an atlas, which we currently don't have. So we need to go to the assets file because we just have map assets. Now we have something new, which is called a texture atlas assets, which also has a path. And there we have an atlas, which we called before. It's here, so we called it game object. And the path to that one is graphics/game object.atlas. So that's the atlas file. And finally, we need an operator for that. So operator function, where we have the texture atlas asset and we return back then the texture atlas, of course. And there we do the same as we did it before, but instead of loading a tiled map, we load the texture atlas. Then we just finish the loading here. So that's a very, very simple approach, which I think should be good enough for our tiny little game here. But maybe in a real game, you don't want to always just load and finish loading immediately. Maybe there you want to have some loading screen where you update the loading and show also some loading progress and so on to the user. That makes, of course, a lot more sense, or would then be a lot better than that approach here. But we have very tiny little resources here, and I think in our case, it should not make a difference. Most likely that's loaded within milliseconds, so players won't notice any delay or lag when we load things like that. I think we should be good to go with that approach. So here we have the atlas. And from the atlas, we want to find a region which has a specific name. So actually we should get find regions because there should be multiple ones, at least one. And the name would be from our object ID, the name in lowercase. And then we have a slash, and then we have the animation type, which was idle here. And that's it. And if that is not available, then we have an error because then we messed something up. There are no regions for object ID and animation type. Otherwise, we have some regions, and here we just can then return a new sprite. And we return the first region here for now. That should be it. So this one here is not ideal, I could imagine, because making the name always to lowercase, it might create always a new string, but I'm not sure because there's always this string caching mechanism also on the JVM. So maybe it just does that once, but not 100% sure. And also here we have some string concatenation. So we have that one, then slash, and then the animation type. So that might create here all the time some string objects which get then collected by the garbage collector and cleaned up. So that might require some improvement. For now, we don't optimize things which are not a problem for the time being. But if there might be some lag in the game at some point, that's most likely pointing to the garbage collector. Then we would need to analyze it if we have maybe thousands of strings which gets cleaned up. So theoretically, that could be a problem. For now, we just ignore it. And that's it. So let's quickly debug this function here. We should end up in here at least once for our player, and then we can check if all of that is currently working. So Chatback Compose is part of Android X Chatback, a set of Android libraries. So it's related to Android. Since Google always defined Compose APIs as Kotlin multi-platform libraries, JetBrains made Compose multi-platform, which is essentially Jetpack Compose plus Psycho, I don't know, never heard of that, is a Kotlin binding for Skia, which is the rendering engine used by Android itself. Android Compose just uses the Android Canvas class, which internally uses Skia instead of using Skia directly. And Compose multi-platform can be used for all Kotlin targets. So this is how it works. So it was initially coming from Android, and now they try to port it to all the target platforms. Interesting approach. And it uses, on the JVM, it uses Java 8WD for desktop apps. Is that a good thing? Isn't AWD super old and there are better alternatives available today, but not sure? Or is AWD the one that works with the native platform or system resources and user interface elements? I cannot remember. Where are we? So here I got a little bit distracted. So here we load the atlas, which was working. Then we want to get out regions, and we did not get any region. Why? Okay, that makes sense because we called this. That's the problem that I mentioned before. So this game object is called player, but actually it should. The player, we called it frog. So we could either name this game object ID here frog instead of player, or we rename this graphic here player, or we make it more dynamically because maybe we want to add some functionality that the player can choose what kind of graphic he wants to have. So we should make here a separate game object. But what would be then the player? The player we used for the tiled collision stuff, but it's actually the frog. So let's be honest, this is the frog. This is not the player. So everywhere where we used it, it's now called frog. What did we do? We have here an entity tag player. Where do we assign that? So if the game object ID is the frog. This is how we solved it. But there is then also one additional problem. I think here we called that player. That should also be frog now. I hope I did not destroy anything with all the renamings from before. Let's quickly check. I hope that can be renamed to frog. No. Cannot open the file for writing. Damn it, why? Why can you not open it? That's a tiny little problem. Not sure why we cannot do that. Is the game still running? No. What did I do? No. I want to modify this one here, and I want to rename that here to frog. I don't know. Something is broken in here. Let's check it like this. Here. We rename it here. Did I do that yesterday? That's a question maybe for Schlaubi in the chat, because he's an IntelliJ expert. If you have any questions about this IDE, you can ask him. Hello, Fatih, and I actually have a question for you, Mr. Schlaubi. So first of all, yesterday I opened these files here and make file writable. So obviously I locked them, which I did not want to do, but I thought it's just some ID thingy, but obviously it locked the file completely. And the other thing is it shows here a lot of errors because I think it's assuming this is a TypeScript file, because it has this TSX ending, but it isn't a TypeScript file. It's just a tiled editor file. And can I somehow tell it, hey, ignore this file with your inspections because your inspections are garbage? I don't care what it tells me here. It's for sure wrong because the files are working. It's coming out from a different program. So I would be interested, how is there a possibility that somehow I can say here, stop inspecting this file and throwing me errors at it? I don't care. Can we do that? But I think I fixed that now. So we made that file hopefully writable again. I hope so. Yes, so now I can save it again. So that was the problem. Interesting. I didn't know that you can lock files in IntelliJ. So when you don't see that. Wait, let me move my... that was wrong. Let me move the camera a little bit. That icon here at the bottom, there is a little lock icon. And when you press it, then this file is now locked. You cannot write it. And it's actually also for the tiled editor, it's then locked. So somehow, I guess it's setting some privileges on the file system that this is a read-only file. But I didn't know that it really does that. So this little icon here below. Interesting, interesting. So can we move the camera back? So I get distracted too much. I need to focus now a little bit. I think we should... Wait, let me check one more time. Do we have player anywhere else in capital letters? That would be the interesting part. We have as an entity tag, which is totally fine. In the family, it's totally fine. And here with the tag, it's also totally fine. So we should be good. Let's see. We have now a game object which is called frog. Now we should hopefully get some regions. Yes, so we have the different frog idle animations. In total, it's 11. Let's check that. Is it really 11? From 0 to 10, that is 11. Yes, so it's 11. And we get the first region. So we get a sprite out of that. So we have a graphic component on our player. And that is what we want. So now we just need to render the player. Also, we would need information where the player is located. Currently, we have the box2D body where we could get out the position. And we have a sprite where we can also set a position. Maybe that's sufficient. Normally, I always create a transform component. And I'm thinking if we need that. Maybe I try it this time without the transform component. Yeah, maybe let's try it this time without the transform component. I never did that, so that's something new, but I don't see currently the benefit of adding it. I think we don't need it. But let's see. So AWD is pretty much just a binding for the operating system APIs. Okay, so it was that one. And yes, it came from Android, but it was always written for Kotlin multi-platform usage, as the Android Compose defines code for other targets as well. However, Google does not maintain a renderer implementation. That's what JetBrains did. You probably meant Swing, which also uses AWD but has ancient UI. Yeah, maybe I meant then Swing. You can... I think at university we made a Minesweeper game with the Swing UI. It looked horrible, but it worked. You can right-click it and assign it the XML file type. Aha, really? How do I do that? Override file type. Haha. Choose file type. Do I really want XML? Is it now better? Yes. Oh my God. Objects? Ha! Schlaubi, I knew it. He's the mastermind. I think he implemented this IDE on it by himself. He knows everything. Cool, I didn't know about that feature. So you can overwrite the file type, which is connected, but just for a single file. That's interesting. Cool stuff. I learned something new today. Thank you. So now we don't have these errors anymore on those files when we check them out. That's good. So coming back to our render system, we want to do a couple of things here because we want to render our entities. So how do we do that? We need to implement, we have here an interval system. It now becomes an iterating system, and we work on a family which contains all entities which have a graphic component. Then here, render entities, that should be the super onTick call, I think. Let me check. That one does the sorting of the entities and then it iterates over all the entities. Yes. So here we make the super onTick call, and that one allows us to override another method, which is the onTick entity. And here we are now rendering, and let's think it through. So we have the game viewport applied, and we already called the batch begin function because we are inside our renderer. So in here, I can simply get the sprite from the graphics from our entity with the destructuring, and we could use now our patch. I think we don't need that. Isn't there a render function or draw function on the sprite? Yes, where we pass in the patch. What does that function do? Patch draw something. So it simply renders the sprite wherever it is currently. I think that's it. So what we don't have, and we don't have the correct position, and we don't have the correct size. For the sprites. So it should, most likely we should see it at the bottom left at the moment. Let's see. Or we simply don't. We do see it. It's that pixel mess here on the right. Because there's also another problem. I give you 5 seconds to think it through. Our sprite is super huge, so we forgot also to scale it down to our world coordinates. That's why we have here that huge pixels here in the background. Okay, what we would need to do. So normally what I do is then not in the render system. So we have maybe different scenarios. For now, we have just one. We have an entity which is always connected to a physics body, and it has a sprite. And we somehow need to link together the physics body position and size with the sprite position and size. And most likely the physics body is the leading one, and the sprite values simply get updated to wherever our physics body gets moved in the physics simulation. Another thing, but we don't have that now, but could be something in the future. Maybe we also have entities which are not linked to a physics body, and they are maybe moved in other ways. Then we would need to think of something else, how to correctly update the sprite position. But for now, we don't need that, so we can simply go to our physics system, and there we already had some code which we did not use before. And here we also the interpolation now also comes in place. So what I did in the past, it seems like I stored the previous position of the physics simulation in the component itself. That might make sense because it's really related to the physics simulation. So I like that. But I think it does not have to be part of the data class. So it's just here a normal property that we can call previous position. And it's vector 2. And maybe to give it some description that if someone ever checks out this code, he knows what it's doing. So this is the position of the physics body since the last physics step call, physics world step call. So it's like this one. So it's the previous position, and that one simply gets stored in here, which is a little bit stupid now, because here we would need to store the components, then we can access stuff here. Yeah, let's still go like that. So here we have the physics component. And from the physics component, we have the previous position, and we set it to the physics component body position. So that's it. Normally, the physics body position is the center of all the fixtures, but I think we aligned it in a way that it's the bottom left corner, if I remember correctly. So I think that should be already correct. This little code here, we remove it for now because I'm not sure. I'm not sure if I will implement it like this in that little game. So let's remove it for now. And here is now the interpolation. So here we want to get now our sprite, which is the graphic component from our entity. And from our sprite, we want to set the position. And how does it work? We need the previous position, and we need from our body the position. Okay, I changed my mind. I want to have this here as part of the data class, because then I can use the destructuring in a better way, and seems like we have that a lot. With a lot, I mean we have it now at least 2 times. And that's why I want to go to the destructuring approach here. Let's format a little bit better. Okay, so coming back here. So here we can now write body and previous position. So we can remove this one here. Position, like this. Okay, and also down there we can now use that, because what we need is here we have the body, and again we need the previous position once more. And now we can also destructor here. So we have the previous X, the previous Y, which is coming from the previous position. And we have the body X and body Y, which is the current position from our body. Okay, and finally we want to have the position, and there I mentioned we will use some interpolation, a linear interpolation, which is called lerp here in LibGDX. We lerp between the previous position and the current position of the body, and we have this alpha value that I explained the last time. So it's like this leftover fragment of a full frame and has a value between 0 and 1. And I think that part we might not need, because because we aligned the body with the bottom left corner. At least in my head we did that. Not sure if we really did it, but let's see. Otherwise we would need to subtract half of the body width and the height so that we get to the correct location. But let's see, I think that should already be correct here. We have one more thing that we need to fix in our spawn system, and that is that the sprite was way too big. And the reason for that was that, first of all, we will use this one here. So first frame, something like that. And the sprite was too big. So the width and the height, can I pass it here? I don't see it. No, so we need to make it here and set the size. We could also use scaling maybe. Maybe we just need scaling. Maybe that's sufficient. Let's see how that looks like now. Okay, it crashes. Why? Lacks no such entity component exception. Has no component of type graphic. Ah, okay. Physics system. We have the ground entities in our game currently. So those one here below, those are also entities, but they don't have a graphic component, but we iterate through them in the physics system. And someone asked the last time, why do we do that? Why do we want to have ground and ground bodies as an entity? And I said it makes things maybe easier for the collision handling if we want to do some fancy stuff. But to be honest, those are static things. They will never move. And information like if it's fire, ground, or if it does some damage or whatever, we could add that anyway, just as user data to the physics body. So I think we don't do that anymore. So let's go back to our spawn system. And we don't create here entities anymore. I think we don't need that. I really think we don't need that. Let's see. That should fix this problem here. Also, let me think. So currently we iterate over all entities which have a physics component. But for sure, we always want to have, let's see. Yeah, we always want to have also entities with graphic components. So we maybe add that here to the family at the top. But let me quickly check. I think now we should not get this error, and we didn't get it. But somehow I still don't see the sprite, which is interesting. Anyway, so here we add now the graphic. Let's see, do we ever enter this piece of code here? World update. And then we are here. So our sprite, how does it look like? It has a position 0, 0. It has a width of 32, and it scales everything down by that value. Might be correct. Not 100% sure, but that might be correct. So when we get to our render system in here, by the way, there's a cool function that I don't use a lot. It got introduced in a couple of updates before in IntelliJ. You have this inlay run to cursor option, that it immediately goes to that specific in the to that location in the debugger without setting a breakpoint, which is very convenient sometimes. Okay, so here we have our entity. We have a sprite. We have the position X and Y, which should be the bottom left corner of our game viewport currently. We have a width, a height, and we have some scaling. Maybe the scaling is not correct. It has the texture with the game object. And yeah, it's somewhere is the frame that we want to render. So why don't we see the player? Is he maybe behind the layer of the map? Let's just render the player graphic. Nah, that's not working. Is the scaling not correct? Let's go back to the spawn system. Also, why is the position 0, 0? It shouldn't be 0, 0 because our physics body is not at 0, 0. We obviously do something wrong. First of all, here, the scaling. The correct value that I normally would set is from the first frame. We have the, from the first frame, we have the width, the original width, the region width, and that one we would multiply by the unit scale. And then we would have the same for the height, which would be the region height. Also unit scale. And normally instead of scaling here, I would say set size, and that would be width and height. That is how I normally did it in the past. Does that change anything? It actually fixes everything. You have scaled it too much. Hello, Seicho. Yes, obviously I scaled it too much, but that looks now perfect. And also it seems like what I had in mind, that we correctly aligned the bottom left corner of the physics body with everything else. We don't need this subtraction with half of the width and the height and so on. Everything looks good. It really looks good. So we can also move now to the right, and the graphic is coming with us. Use division. I'm still, okay, so that obviously fixes it, but why does the scaling not work? The scaling is divided by 16. Let's debug that and understand that. I don't understand it. So I have a width of 2, which makes sense because our world unit, so one tile is 16 by 16 and the graphic is 32 by 32. So width and height are 2. It's actually 2 world units. If we used the scaling that we had before, what value did we get then? So let me close that here. S2, and we use here again this set scale, and we pass in here the unit scale. And what kind of values do we get here? Divided by 16 should be correct because 32 divided by 16 is actually 2. So S2 width is 32. Why? Is there something like real width. And scaling that is 1 divided by 16. But we actually need to scale by so we would need scale relatively. So currently we scale down by 16, I guess, which is wrong because we just want to scale it down by half. So to get from 32 to 16, something like that. So this scaling does not work. Most likely it's something 1 minus something. I don't know what would be correct. So we just stick with the approach that I normally use, which is that one. And that one is working. That's the important piece. Good. So I think we are now golden. We are. What we did not do yet, and let's also quickly add that. First of all, we can bring back the map itself, the rendering. And what we did not do is one more thing. So that's the family, family argument. And there is also a sorting. Or is this compare? So the comparator. So we want to sort entities when they are overlapping. So basically, imagine we have 3 sprites overlapping like that. One of them must be rendered first, the other one rendered last. If we don't have an order, you will get some flickering because it's then a little bit random how they are rendered. It's not completely random because Flex is iterating through the entities in a specific order. But anyway, it's always a good approach that maybe your player is always in the foreground, other things are maybe in the background. And usually I think it's sorted from left to right and top to bottom, something like that. We won't test it yet, but we will say that we want to compare. I know I remembered I added some nice utility functions here as well. Compare entity by. And then I pass in the component type, which could be graphic. And now the graphic just needs to be comparable, I hope. Comparable graphic. And implement a method. And that's it. Yes. Okay, cool. So there is an easy function for that. So the compare entity by. And now we need to implement how we want to compare. To be honest, we just copy and paste it from another project. And I'm just thinking, where did I do it the nicest way? I think maybe in Mystic Garden. How did we do it in Mystic Woods? Let me check. In the Flex 2.0 branch, because there I optimized certain things. And there we sorted by the transform component, or how did I call it? Animation, blah, blah, blah. Position component. I don't see that. What did I use here for the comparison? I know that I always use some comparison. Compare entity by image component. So we had an image component. Where is the image component? And there I compared to this one. I don't like that one. I remember I had some better method for that. Did I use that in Mystic Garden Kotlin branch? Again, like last time, I know that I did certain things, so I know I don't need to remember it. I just need to find the pieces and then copy and paste it. So I think that's the one that I want. So here we have a graphic component. And the layer could be actually useful. We don't have that yet. But we could make, for example, that the player is always in the foreground. So that's really maybe some nice thing that we want to have in the future. But default, it's just 0. Then, or that's actually then the C value. Okay. And for the other thing, we have the sprite dot something. Yes. Then the sprite Y, sprite X. Like this. And here we have the other sprite, blah, blah, blah. Like that. So that one I like a lot because it's, at least for me, it's very easy to read. So if my C is smaller than the other C, then I'm behind it. If my C is greater than the other C, then I'm in front of the other entity. Same with the Y coordinate. And the last thing to check is the X coordinate. So that's it. And if nothing is different, then it's the same. It doesn't matter. Then it's 0. And that should hopefully still work. Oh. Random generator factory all. What? Where was that coming from? Okay. Looks good. Actually looks perfect. Let's quickly check one last time. Is it really good? So our box was, we have here this little bandana, red stuff, and there is this black line here, and next to it there should be the left edge of this rectangle. That looks perfect. The top one is below this green stuff, which is also perfect. This ellipse stuff is exactly at the top of the black lines here, which I also see here. Maybe you don't see that in the stream, might be difficult to see, but on my screen I can see here a difference between that black color in the background and those black pixels here of the sprite itself. That one also looks good. Yeah, I think everything else is then also perfect. So that one is just next to this black thing here, which is also correct. Yeah, so for me, it looks perfect. I think we aligned everything correctly. And we now have a graphic. I hope I can afford a decent laptop that can run LibGDX projects on it. My laptop now can't run the desktop app. Really? Because I bought a notebook, I think 3 or 4 years ago, which was really not expensive. Let me quickly check. I also have thermal paste if someone is interested. Here. It's a leftover. Because when I bought the new PC last year, I bought, I think Thermal Grizzly was the brand. And now I have some leftover Thermal Ride thermal paste, which was coming with the cooler of the CPU cooler. But anyway, the notebook, I have an Asus VivoBook, if you can read that. And that one was not expensive. I think it was 450 euros, something like that. So not super expensive. It did not have an operating system, but I simply installed then Kubuntu on it, so a Linux distribution, which is, my opinion, similar to Windows, at least for me, with handling everything. In certain things, I like it more than Windows. In certain areas, I like it less. But that one is more than good enough. So there I run my projects as well from LibGDX. And that one is working. So you just need like, I don't know, 400, 450 euro for a notebook. that should give you more than enough power. Good. What I want to show you now is one more thing, the interpolation. Also for myself to see that it's really working. What I mentioned last time, let's imagine we update our physics simulation just once a second. Maybe to get the effect even better, only every other second. So you see now, I need to maybe spam the button to push the player, not sure. The problem could be, wait, in our game screen, we have this is key just pressed. Maybe if is key pressed, something like that, then I don't need to press it perfectly. I hope that works. Let's see. We can see it at the beginning. So the sprite is actually coming from the bottom left and slowly interpolating up to the real body position. Okay, but now you see it. So we just update the physics simulation every other second. So you see the body is moving instantly because of the simulation. After the next step, we just moved a certain distance. And our sprite is then not teleporting around. It's then really slowly interpolating from the last time we called the physics simulation and the current time when we called the physics simulation. So this is this interpolation stuff. So that's maybe, or I think that's very usual, and I had this problem many, many times. You don't have a fixed amount of frames. There's always a little bit of a difference, and sometimes you might have, I don't know, 1 or 2 physics system updates more in a second than usual. And then if you just always set the player or the sprite position immediately to the physics body, then you have a little bit of a stuttering, which does not really look nice and feels a little bit weird from a player point. You really notice that something is wrong. And with this interpolation approach, you don't, or at least I don't see this problem then at all, because it's then really nicely interpolating between different locations and it's not immediately teleporting around. So there's always some fluent motion, which looks then very good. So that's working. So let's go back. No, here we leave it like we had it, but in the physics system, we go back to this 1 divided by 45. Okay. The minimum wage on our country a day is only $10. I can't even support my family. What the hell? Where are you from? $10 for a day. Eastern Europe maybe? Or where is that? But even there, I thought they have more income nowadays. I know some of you know it, but my wife is from Laos. It's a country in Asia between China, Thailand, Cambodia, Vietnam. So there is Laos in between. And that's also a very, very poor country. So there, for everything that they need to pay, it's like a fifth or even a tenth of what we need to pay here in Austria. That's why I always like to visit her family, because it's super cheap. Like a Coke is, I don't know, 20 cents instead of €1.50 or something like that, which is nice. Good. That, to be honest, it took way longer than I would have imagined, but it's working, which is great. So we have a render component. We just needed a sprite. We have the sorting and everything. So we can make that here like this. So what we wanted to actually do is to optimize the player control, which we did not even start yet with a normal implementation of a player. but let's do that now. We have more than enough time. But first of all, let's commit. By the way, also one more thing, and one thing that I need to fix that I remember. I updated the README file a little bit. So normally there's some default text in it from the GDX liftoff setup. And now I added some batches that when people go to the GitHub page, they can see which Kotlin version, with Flex version, with LibGDX version, and so on. There will be then some description and screenshots later on. And I also like to give credits to whatever I use. And there I wanted to add the command from, is it hopefully still in my history? No, it's not there. I need to start maybe the power, no, not power auto. What the hell is power automate? I mean PowerShell. Exactly, and there should be this tile extruder command, because that one I also want to paste here below so that I can simply copy and paste it in the future. So tile width 16, tile height 16, then margin, the amount of margin that we want to have, spacing. But I think that one was wrong, right? We just needed the extrusion, and input was then the tile set PNG, and output was the tile set extruded PNG. I think this is how it worked. Tile extruder, tile width, tile height. We did not have margin and spacing. We extruded 2 pixels out of them, if I remember correctly. And that was the command. Okay, so that I always have that here available and I don't need to look it up again and again. There was, by the way, a crazy guy this week at work. There was an Angular expert, which is currently working on a pilot project for a company that I work for. He's replacing very old Struts 2 user interface applications with Angular. And he was showing me something this week and wanted to get some feedback. He also needed some help with certain backend stuff that he also needs to work with a little bit. And that guy was a crazy console guy. So I knew, so he loved Linux. You could totally see that because he did nothing with the mouse. Everything was in the console. So always, I didn't even know how he did it. So normally when you are, at least this is, I hate console. I'm not good at it. So is ls a command here? No, I think it's in the PowerShell. I think there you have some. For me, it's Linux commands, but not sure. Yeah, exactly. So he was here, then always ls something, and then I don't know how he did that, but he remained in the same directory, but somehow listed files from a completely other location of his dev container in the Docker container. Then he modified the files. Was it Vim or V or something? So everything was done in the console. He was, to be fair, he was really fast, which was super impressive. But I hate that. So I couldn't, never for the life of it, I could imagine all these commands that you would need to type. Like he had to install certain things, and then it was like, I think apt is this package manager, install something, and from the top of the head he knew that he needed this image and that stuff and that package. I'm not that guy. Maybe I'm too old for that, but I'm always impressed by people who can do that. And yeah, he was super fast. It was quite funny to see people who are very familiar and fast with those console stuffs. I'm not one of them. I'm super bad. Okay, so add render support and graphic components or something like that. This is what we did with that little commit here. What is the mind map program? The mind map program is a new one that I tried out. And it's actually funny because I needed a mind map program on my phone because I wanted to write down some thoughts that I had a couple of weeks ago and search the Play Store. And in the end, I found an app which was really nice to use on the phone. and it was called Nice Minds. And I saw or found out that they also have a Windows version for it, which I'm using right now. And I think it's good enough. So it has quite a few features. So you, for example, what I like, you cannot only display the mind map here, you can also have a mind map and an outline here at the left, for example, or just the outline. So you can have different representations. Also, there is a ton of different templates that you can use. So color layouts, you can switch them very quickly around. I actually prefer that one more because I like dark themes from time to time, but for me personally, it's just easier to look at light themes. But since a few people complained last time that they want to have a dark theme, it's easier to look at it on the phone and so on. So with that stream and that project, I will stick to dark themes. So that's also working here, which I like. Then you can export it to PDF, to a graphics, also to an image and so on. You can collapse the different levels very easily. And the only thing that I can complain about, also there are, you can add emojis, you can mark certain things with certain icons and so on. For me, it's very good to use. Also, some hotkeys are good, but I'm missing certain hotkeys from another mind map tool that I use, which would make it for me a little bit faster. There is, funny enough, there is a feedback button. And I gave already quite a few feedbacks here with regarding hotkeys and so on. I never got any response, and they released an update a few days ago, and there was no suggestion added at all. So I don't know if this feedback function, maybe it does not work, or they simply don't care about my feedback. I don't know. That was a little bit weird. But yeah, anyway, what I'm missing here are certain hotkeys. Like, for example, you can navigate around between the topic and the subtopic. Don't know if you can see that on the stream, but with the arrow keys, you can navigate, which is good. What I am missing is a hotkey to close and open a topic. In the old program and in some other programs, it's space. But for whatever reason, space in that program is that you want to edit the current node and start typing, which for me normally would be F2 in Windows. I think that is renaming, but that doesn't do anything in that program. So that is weird that I cannot open and close these things. Also, what I normally want to have is that I want to quickly move a subtopic up and down, which in most programs that I used was Control and then the arrow key up and down, which doesn't do anything in that program. So you need to do it per mouse, that you need to move it around, which is not so fast. And the last thing, what I'm also missing is that when, for example, I select the topic here, and with the shift click, I want to select all of the topics below. So like this one, like that. I want to achieve that with a simple shift hold and then click down. That doesn't work. But what I found out, at least what is working, you can just drag and drop the mouse over the topics, then it gets selected. I didn't know about that. I found out about it I think 2 or 3 days ago. So that is okay-ish. But that's the only complaint that I have. Also maybe, but that doesn't really bother me. When I collapse it, there is a number next to it, which tells you how many topics you have below that. And there it says 12, which in my opinion, yeah, is not really correct. So the immediate subtopics would be 4, but those topics again have other subtopics. So it simply sums up everything that is below. So that's why it mentions here 12, although there is just 4 subtopics. But those are just some minor things. So in general, I'm very happy with that. And also I like it that it's working on the phone and that you have so many options regarding the layout and everything. And it's really responsive. So it's quite fast and good. So I like it. Let me share the link if anyone is interested. From what I know, it's free. And maybe, I don't know, maybe it uploads certain things in the background. I don't really care. Even the laptop I bought in 2012 runs the LibGDX project. Yeah, so I'm really wondering what kind of laptop you have. My laptop is from 2009. I test my project on a physical device because I can't run it on emulator or desktop. Do you mean the Android emulator? That one I could understand because that one is quite resource heavy. Even back then on some of my computers, that one was really not running very fluently. They optimized it over the years that it's better, but it's still, in my opinion, an heavy emulator. So that one I could understand why it's not working that great with your old laptop. I have only used Xmind before. That one I know from the name. So the mind map games that I know, the mind map apps that I know are FreeMind, which I used a lot, but that's a little bit buggy and old and gets no updates anymore. So I tried to get away from it. And also iMindQ, that one I think you need to pay for, but there were some licenses at my old company where we could use it. But I hated the hotkeys of that app. Many times I deleted nodes by accident and had to revert it. Also renaming was a very weird hotkey from what I remember. So I sometimes switch then back to FreeMind instead of iMindQ. And yeah, now I know this NiceMind, and yeah, I use that one now. And yeah, NiceMind runs on the phone. Let me check. I think I have it still installed. Yes. And I think I can show you that one here. I hope that no one is calling me right now. But here, this is how it looks on the phone. So it's an app, also quite easy. So you can click on a node, then you get some buttons where you could insert a subtopic and so on. So of course, on a phone, it's not super fast to create a mind map, but it was good enough for me, and I was happy with the feeling of it. I installed it. Great. Good. So let's come back to our little game because we want to move forward with it, and we want to actually get now some player control into it. Here with player control or with input handling, I'm still not 100% sure what the best approach is. There is quite a cool website. Is it Game Design Patterns Gang of Four? Something like that. Can I find it like this? Nah, it's not that page. I think it's that one. Is it that one? Command. I think that page here. Let me share it with you, which is a really interesting read. And not sure if it's exactly that page. I cannot remember. But it explains certain patterns which I find really cool because, for example, when you think about it, modern games, for example, an RTS game like Warcraft 3, even nowadays Counter-Strike 2 and so on, there's always this replay functionality. And obviously they don't save like a video and then you replay a video, which is the replay. That's not how it works. It's more like, from what I understood and from the pattern how it should work, is that you have inputs, so little commands that get maybe captured every frame or every 10th of a frame. And when you have your game, which is basically also just a simulation which runs over time, and when you fire those commands again and again at the same time, you get the exact behavior that you would have when you play as a player. So the replay of an RTS would be then that I pressed that second one, I selected a unit with the left mouse button, and then I clicked at a certain position with the right mouse button, and the game simply captures those events, and in the replay it's then simply firing those commands without me doing it. It's then programmatically firing these events, and then the simulation is happening exactly like the real game. And there he describes some approaches, so how you can abstract that a little bit, also in like in GIMP, for example, or in a drawing app like Paint that we have here. So everything that we do, like here I draw the circle, then that one, then that one. So those would be 3 separate commands, which are memorized now by the application in the background. That the command was draw maybe line from point A to point B. And now when I press Control C, it just loads the last command from the command stack and calls a revert function on that command, which basically in that specific case, it removes the line that I was drawing. So there would be a command stack, and then you can go back on this stack or add some new commands to it, which is a behavior that we see, for example, in this painting application. And it's a little bit described, if I remember correctly, on that page at some of these patterns. And I always thought that, okay, from the theory of it, that sounds great and cool, but I never know how I should implement that in a way that it's good for me. What I did in this proof of concept that I showed in one of the videos was that I created a so-called controller, because what I thought of, and it's also a little bit explained on that page, that our game has a player character, and that one can be controlled by me as a player via a keyboard. So we would have a human input keyboards controller. So when you press certain keyboard buttons, then we fire certain commands to our player that he's doing something. Then another controller, so like a class, a separate class, would be then maybe a player controller, where we have an Xbox controller, and then whatever buttons we press there, in the background we fire the same commands that we fire with the keyboard controller. And then maybe like a demo controller or AI controller, where programmatically some input events are fired and things like that. But it's like an abstraction layer, let's say. So we have the controller class, which is just getting the inputs from, in our case, we will use a keyboard controller. So it's getting the input events from the keyboard. And based on certain keystrokes, we are then firing let's call it a command. A command could be a move command or a jump command or a buy command if we buy a certain item. So things like that. And also our game will for sure have 2 input controllers. One would be the keyboard to handle the player with or control the player with the keyboard. And the other one would be the scene 2D stage, which is the user interface, which also must or is some sort of controller, because when you press a menu button, or maybe on your phone you touch on the screen and press a certain menu button, then also something should happen in the background in our game. And in LibGDX there is a so-called input something. Is it called input controller? Input processor. Okay, they call it input processor. And there is, I think it's just one global processor, which is then responsible for taking in or handling input events. And here we could, for example, assign then our player keyboard controller. But since we have, as I mentioned, we might have multiple controllers, maybe the keyboard, then maybe we also want to support the Xbox controller, then also the Scene2D UI stage. We will have something that is called an input multiplexer. How is it called? Input multiplexer, which is basically an input processor that goes through a list of input processors. So we register here then the keyboard controller in a moment, and in the future then also the stage, the Scene2D stage, then maybe also the Xbox controller. And then this multiplexer simply iterates through all the processors which are registered, and all of them can give some input events. And yeah, what I want to do here, so initially when our game starts, we already create this input multiplexer, which at the beginning has no controller at all. And now we do something. So we create a new package and we call it command. Let's call it input. Is input a good package name? We just roll with it. And we will have a player keyboard. Maybe we should then stick to this name and call it input processor. Player keyboard input processor that I created today at 15 o'clock. Just kidding. But that name is ridiculously long. Can we maybe make it a little bit shorter? Just keyboard input processor. Let's remove the player part of it, that it's at least a little bit shorter. And that one is is there a KTX input adapter? There is. What does that do? It's an input processor with maybe just, what is the, it's an interface instead of a class. So that's the difference. Okay. And what we want to have here, we want to listen to currently just one type of events. Actually, we need two. We have key down and we have the key up thingy. And there we want to listen to the A and D button like we had it in the game screen before. That's it. Then in our game screen, we want to do something now. So this debug controls, let's get rid of them. We don't want to have them. And also one more thing. First of all, in the show function, when we are here, then our input processor, which we know is a multiplexer. Input multiplexer. Casting is not done like that. Wait. How is it done in Kotlin? As input multiplexer, is it like this? And then we want to add a processor. And that one, does it need an input? Yes, it actually does need an input. So for sure it needs the world, because maybe it does not need to remember it, but it needs at least the entity world, because it needs to iterate then again over all player entities and fire specific commands, so that we want to move to the left or right. So things like that. It needs access to the entities. So it has to be a class. Yeah, I think that's enough for it. So for sure, somewhere here, maybe here, we need the keyboard processor, which is a keyboard input processor, and that one gets the world. So we need to move it down there so that we have the world available, and then we pass in here the world so that we have this controller then active. And the other thing is the hide function. So when we move away from that screen, then I don't like this cast. I will, not sure if we can optimize that, but let's see. Then we want to remove the processor. And also one thing that we forgot here, instead of register all the systems, we also want to unregister the systems if we are at a different screen. Good. What is that? That is a static reference to an input interface. And that one is... Okay, so what I want to have, I guess, let's quickly check. So I want to have an extension function which is based on the input class, and that one gives us the, let's call it input multiplexer, which returns an input multiplexer, and that is simply GDX input processor as input multiplexer. So we have here this cast all the time. We could, isn't there also an extension val? But there we need to have the get function. I think it was like that in Kotlin. And with that, I think we can then write here GDX input multiplexer, right? So we don't need this cast here all the time. We can access it directly. Okay, that worked. Aha. At least I hope it worked. We didn't try it out, but I think it should work. So it makes it a little bit easier. So because, as mentioned, we initialize it here. So we will always have a multiplexer. It will never be something else. And instead of casting all the time and do something weird, we just make here the extension function. And that's it. We could actually have here this input processor. Now it's correct, right? Yes. Hello, again, missed the beginning of the stream. So this is hello from the, I have here a little heart all the time. So I cannot read the bottom right of the chat message, which is annoying. The 10th minute something the stream. I don't know how I can hide that. Do you even see when I press this hard? But hello, Nevdati. You missed awesome stuff today. You need to rewatch the beginning of the stream. So we have our input processor, and theoretically, when we press now a button, we should end up in here. Let's see. Okay, where's the game? I press a button now, and we ended up in this function. Great, so the setup of this processing is already working, and now we want to do something. What I find a little bit weird, yeah, it's not really weird. I understand why they have that, but I never really used it. So this key down, key up, and other input methods, they are returning a Boolean, as you can see here. And the reason is that, like in our case with the multiplexer, that there are multiple listeners for a certain event or processors for a certain event. And when you return, I need to look it up. When you return true, it tells the processor in the background that the event was handled and it should not populate it or fire it for any other processes that come later on. And if you return false, then the next processor gets the event as well. Something like that. So whether the input was processed, yes. And that way you can somehow interrupt the process chain. But for me, I could never imagine why I would do that. So normally when I have an input event, I always want that all the processors get it and either they react to it or not. I could imagine that there are scenarios where you don't want that, and that's most likely the reason why they introduced this Boolean, but we don't want that, so we just return false. And now if or let's use the when. I love the when, but since I don't have it in Java, I always forget to write it down. When the key code is the keys dot, or is it just key? Is it keys? No. What is the correct one? Input.key. Where is it? Key.arrow something. We had it in the game screen before. why can I not find it? It's called, let's go down, input.keys.d. So that's the one that we need. Then we do something. Okay, and when branch is never reachable. Why? I don't get it. Let me write it down differently. When key code equals input keys D, then do something else if key code equals A, then do something else. Okay, let's think a little bit how we can easily implement it. So, of course, when we press D, we want to go to the right. When we release D, we want to stop the movement unless you also pressed A. So, I think I might have a smart approach for that. So, we have here let's call it move horizontal or move X, which is by default 0. And when we press D, then we increase it by 1 because we want to go to the right. And when we press A, then we want to reduce it by 1. Which means when we press D and A afterwards, we stop moving. Also, when we press A and then D, we also stop moving. I think that's an intuitive behavior, which is fine. Then, I think now I can replace it with a when statement and do something like this to keep it a little bit shorter. And the same when we release the buttons, but it's the other way around. So when we release the D button, we reduce it by 1. And when we release the A button, then we add 1. Let me think that through. We press D, we are +1. We press A, we are at 0. I release D. And since I pressed A before, we are now going left. And if I release A, we should stop because we are then at 0 again. In theory, that should work. And now what we want to do is, first of all, we need the players here. Player entities, and those are simply all entities which have the entity tag player. That also, by the way, if we, for whatever reason, maybe a feature in our game, if we would have a second or third entity which also has this tag, then they also get automatically controlled here with whatever we are implementing here. So that's a very generic solution. And what I want to do, so the movement itself, I don't want to apply a force or an impulse to the physics engine below. I want to decouple that. So what I want to have is like just a move component, and there with, we need to check that out, what feels then the best. But in LibGDX, there is an interpolation class, and there I simply want to slowly over time start from a specific move speed that we have currently to a maximum one over time. So like here we would start running very fast, or if we would choose this interpolation, we would start running very slowly. We will have, I don't know, maybe something like that, power 4 out or power 5 out, that we reach maximum speed almost very fast, something like that. But this is what I want to do. So in the background, it's just setting a move speed number, which is also then easy to write a test for. and we don't need the complexity of the physics system with that. And in the end, so we have then this move component with a move speed value, and then in the physics system, there I just want to check, does the entity have a move component? And if yes, and it has a specific move speed, then I apply the impulse according to its current move speed so that it represents the value that we are calculating independently from the physics system. So we don't have a real physics behavior, I would say. We can implement whatever functionality we want to have with accelerating and so on, and the physics system simply gets fed in the numbers that we calculate and does the simulation for us. I think that should be a good approach. At least I hope so. So how do we pass this now to our player entity? So as mentioned, we need a new component. And before we do that, I want to try something out because I want to check out the live template once more. Not sure if that works, but I just want to see if it maybe works. So live template, Kotlin, and we have the flex component. Can I add import statements to this live template here at the top? Does that work? Let's see. So we have a new component which we call move. And let's try it out. Flex C, move the data class. And in here, we have, what do we have? We have the current speed. Let's call it actual or current. Let's call it just current, which is a float. We have a maximum and maybe also a time to reach maximum. So how much time should it take to reach the maximum amount? So time to max, which is also a float, and also a current timer or just timer. Let's call it just a timer. That would be the current timer. Okay, I want to have this on separate lines. So with the destructuring, that it also makes sense. So we have the current move speed, we have the maximum move speed, we have the time to reach the maximum amount, and we have a timer. I think that's everything that we need. And that import statement stuff that worked. So sorry, but I want to update the wiki briefly so that I can use that also in other projects and other people also can use it in other projects. So in here, edit, and there is the live template, and there we add those import statements as well. Okay. Because that worked. I did not know that you can add import statements to the live template, but that makes it easier because otherwise it's always asking if you want to add the AWT component or the flex component, which is quite annoying. So we have it now like that. Good. So we have a move component. One thing that we are missing, let me think. Somehow, so when we have now the move system, which is updating these values, how does it know that we want to move to the maximum? That we want to move somewhere? And also, if we want to stop. Can I fix it? I mean, we can set, if we want to stop, the maximum would be 0. And if we want to move, yeah, but then it would do some calculations, all the stuff. So maybe it should skip then certain things. Also, the direction here is not clear if we move to the right or to the left. So we might need two additional things. Let me think. The first one would be like or just do we just need the direction? Let me think. If we would add here another thing, which would be the direction, which is an integer, -1, 0, and 1. We could also make that an enum, but that doesn't matter. Does that help us? So when we set the direction to 1, the system would know we want to go to the right and does some calculation. If we set the direction to 0, it knows we want to stop. And if we have some move speed, it will stop us. If we set it to -1, it would know we want to go to the left and also does something. I think we can then control if we want to move or not via the direction. And for that, I would say we can use a sealed interface or just an enum class. In Kotlin, you cannot have something like in TypeScript or JavaScript, right? That I have here like move direction. And that has the values -1, 0, and 1. Something like that. And then you can only use those values. Not sure if that feature is available in Kotlin. So we will go with an enum class, which we call move direction. Unless someone in the chat tells me there is a nice feature. And we will have move direction left, which has the value -1. We have move direction none, which has the value 0. And we have move direction right, which has the value 1. And that one has then the value, which is an integer. And then the direction below is the move direction. And now I'm just wondering, maybe we want to, when we destruct it, we want to have the current, the maximum, the current direction. So those two are the important ones. Maybe even the direction first. Then current maximum, current timer, maximum timer. And that's it. Okay, and then back in our controller, the only thing that we need to set is for all of our player entities, we want to get the move component and we want to set the direction to move direction. And then maybe off. And there we just pass in the value. Because, of course, we could make that an enumeration as well, but then we cannot do it like here with just +1, -1 and things like that. We would need to set then move direction values, which is a little bit annoying. So we will just create here a member function of the companion object and call that here value. And that one is quite simple. So when the value is 1, also return, then we return right. If the value is -1, we return left. And otherwise we return none. I think we can also make it a little bit shorter like this. And coming back to our controller, that's it. Also, wait, because currently also if we would press S, W or any other key, we would still update here the player. The stream still there? Reconnection successful. I think you lost me for a moment. Let me check if we are still live. Hello, hello, hello. Hello, hello. Okay, I hear myself. I think the stream is still working, I hope, but you lost me for a moment. Okay, maybe some internet troubles. So instead of having here all the time this one and then the player update call in here, we will make a separate method in here. Let's call that update player movement. And there we pass in a value. In that case, it would be 1. And down below, it would be -1. And we can then call this function from everywhere. Let's call that move value. And what we do in here is, first of all, we update the player movement. So this move x plus equals whatever the value we get in here. And then we set the direction in the move component to the move direction, which is the result of that move x. And now we just need to copy and paste that here as well. So this is -1 and this is +1. So in theory, that should be already everything that we need. Let's quickly make now a move system, and then I need a short break. So let's create a move system, which is an iterating system with a family which iterates over all entities which have a move component. Do we need anything special in here? Wait, one more thing. That one was used now. Okay. Okay, so in here, we want to destructure the move component. Is there, by the way, some create destructuring declaration? Ah, that's cool. So there's some post-fix extension or whatever that is called, which is cool. So we have the direction, we have current, we have maximum, we have the time, and we have the time to maximum. Okay, and before we do anything in here, let's make a print line here. Let's make a breakpoint. And the last thing that we need to do is first of all add this system to our processing systems. In my opinion, it should be before the physics system, because here we are updating this move value, and in the physics system we want to apply then the updated move value. So now we are getting already processed, and in the spawn system, when we have the player, then we add a move component to him so that he can move, and the maximum move speed would be, I don't know, 3, so that he can move 3 tiles per second, which is maybe quite fast. Let's reduce it to 2. And the time to maximum speed would be that he reaches that after 2 seconds. But let's say then 3 here. What is that? No value passed for parameter current. Ah, and we might need... So move direction per default is none, of course. Current is always 0. It does not make sense to set something immediately. I would say you can do that, but it's not necessary. Maximum needs to be provided. Timer is also 0 by default, and time to maximum also needs to be provided. So those two things here, they need to be passed. And I think, let me check. If we have it here, I'm pretty sure that that does not work. I'm wrong. It does work. How does that work? Kotlin magic. Because normally, I could imagine we have default values here, but we don't have default values here. So obviously you need to pass parameter 3 and 4. And to get to those, you anyway would need to pass a value for parameter 1 and 2 or for argument 1 and 2. But seems like Kotlin magic with named arguments simply helps us in that case, and it works like that, which is nice, and which also does not mess up our destructuring order, which I like. So timer, and we had it the other way around, so like this. Yeah, so cool. So the destructuring order is then also still working. We should now end up in this breakpoint, right? So we have here an entity, which is our player. He has a maximum move speed of 3 and time to maximum is also 3. Perfect. So that is something that we can work with. And now I think the system is rather simple. So we just need to update now the timer with the delta time and interpolate with the interpolation class. And I don't know, what did we say? Power out 3 or power 5 out, something like this. And then we can apply it. The start value would be, it's always 0. The end value is our maximum move speed. And the alpha value would be the timer. And the timer itself simply needs to be added with the delta time. Here, I'm not sure. I think we need to get the components as well, because otherwise we cannot set the timer. I think with the destructuring of a float, you cannot destructure the float and set it and update it inside the component. I think that doesn't work. So most likely we need to extract that here. We have the move component. And then in here we need to write something like that. I think like this. Here we could, of course, write var instead, and then we can do something like this: timer equals timer. Then we can work here with the properties, modify them if we want to, and do it like this. So yeah, so something like this we need to do, but I need to make a short break now. But seems to be simple. And in the end, what we need then is the value that we calculate here. We need to use that then in the physics system to set the correct speed of our player. But I'm now gone for 5 to 10 minutes. I play you some music, as always. And I'm then back, and then we continue with the system here. So what kind of music do you want to hear? Not sure. Yeah, I think I cannot play everything because of this copyright stuff. So even old Super Nintendo thingies music, I think they will not be happy if I play them, and then maybe some part of the stream is muted or things like that. So you will get some no copyright music. And I'm then back in a moment. Okay, I'm back. Hello. So, what I wanted to update first. Someone will laugh again, but I'm sure today we will not be able to finish everything. It's too much for me. What we will do. So, second day. Today we will finalize for sure the movement, so the left and right movement I want to do and finalize it, which is I think one of the bigger parts. Then tomorrow we for sure make a stream. There we will implement the jump mechanic. We will also do then this coyote time and jump buffering stuff so that we have a little bit of better control. Then we will write some basic tests for the move system, for example. And we will also introduce this GitHub Actions. So that is what we will do tomorrow. What is day 4? On that day, I could imagine that we will also be able to implement animations maybe. But let's keep that for the real day 4. We already have fake days here everywhere. For today, we want to finalize the movements. Then I want to eat something. Okay, let me take another sip of a drink where I'm not sponsored with, and since I don't drink coffee, I need an alternative to keep me awake. Perfect. So move system, it gets called every time. We have a timer, where we add the delta time, but actually we want to have a maximum of this timer. So how can I write that? I think like this, right? Timer plus delta time, and the maximum time is it time to max? I think so. Yes. So the timer should stop at some point when we reach the maximum time. Oh, that's bullshit. It's something completely different. I'm wrong. So the timer at most takes the value 1 because the alpha value is between 0 and 1. So the timer starts at 0 and goes to 1. But it might go slower. So the time to max. So we need to change the delta time here a little bit. It's not just delta time. That would be when the time to max is 1 second. But it might be more than a second. So it's multiplied by, let me think. Time to max minus 1f. That would mean, so if time to maximum is 2, no, that's for sure not correct. Is it 1 divided by time to max? Let's think that through. So if time to max is 2, that would mean 1 divided by this value here is 0.5, so we would multiply delta time by half of it, which would mean it takes twice the amount to reach to 1, which would be correct. If time to max is half, then this one would be 2, so delta time is twice as fast to reach 1, which is also correct. So 1 divided by that value. Theoretically, you could say time to max is 0, but why would you do that? Then, of course, it crashes here. But time to max of 0 does not make sense. I think that should be good. So it's timer plus this delta time, and the maximum value is 1. Then we interpolate the current value. which is a value between 0 and the maximum move speed that we can reach, with the timer, which we also need to update here. And finally, what we did not use yet is the direction. So here we want to have a little bit of the logic. So if the direction is not equal to move direction none, which means entity wants to move right or left, then we want to update those values. And I'm just thinking, if we would go to the right and then somehow make a turn to the left, I think we want to start again then from speed 0. So we need to reset the current value here. Also the timer we would need to reset. So if current is greater 0 and the move direction is left, that would be the first option, or current is less than 0. Yeah, and move direction is right. Direction. I forgot to write it like this. So we move to the right, but the input said we want to go to the left. Or we move to the left and the player input said we want to go to the right. So we want to change direction. In that case, we want to reset current to 0 and we also want to reset the timer. And still, we want to update it, maybe. So either that one would be part of an else, or we leave it here. I think we update already in that framework, but let's see how that feels then when we handle it. So then we would update the timer again, and our move speed interpolation would be between 0 and maximum. How would we ever go to the left side? I'm wondering. I'm also not sure if we need that, because we could always multiply by the move direction, but then this check here will never be correct. Let me think. That's a problem that we need to solve. For now, I just want to get that going somehow so that I can feel or see at least if that is working somehow. So that's for sure not yet 100% correct, because changing direction will not work properly. Otherwise here, so if the move direction is not then entity wants to stop the movement. And here I'm thinking, for now, let's make an immediate stop. Later on, we maybe want to just slow down the entity. So we will set here current to 0, the timer to 0, set the values again, and return. So we will stop here immediately. That's it. So I think that's right now everything that we need to do for the update stuff. Yeah, so this assignment here does not make sense because we assign it here below. Anyway, this is not 100% perfect, but it should get us going somewhere. And in here, in the on-tick entity, so in our physics system here, we want to check apply move impulse if entity has a move component and is moving. So we have something like entity get or null move. And if it has that, so if it has a move component, then we want to apply the impulse and move it immediately to that specific speed. And there is a formula for that, which I, of course, don't remember, but I know there is iForce 2D. That's the documentation for box 2D. And movement impulse, something like that. There should be hopefully the formula in there. When I see it, I know it. So that was not it. Moving at constant speed. I think that's the one. Setting velocity directly. So you can do that one, but from what I know, that's not recommended and breaks the physics behavior. Trying this code in the testbed, you will see that this setup gives us the instantaneous speed scenario. To implement a gradual acceleration up to maximum speed, you could do something like this. This will increase the velocity linearly by 0%, blah, 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 blah. With the default testbed frame rate at 60, or just under a second. When coming to a stop, the speed is reduced to 98 of the previous frame speed, which comes to about blah, blah, blah. An advantage of this method is that these acceleration characteristics can be easily tuned. That's interesting. I thought you are not, or you should not set the velocity directly. Before we get started on the force interval, let's see how set linear velocity works to directly specifying the velocity of the body. For many applications, this may be good enough. That sounds way easier. Because normally with the impulse, you need to consider, that's the formula that I wanted. So you need to get the mass, you need to get the current velocity, and then somehow calculate whatever you need to do with the world center and so on. So that's a little bit more complex, but would give the same result. But for the first time in my life, I swear that this section here was not available a couple of years ago when I checked it. But that sounds rather simple. So we just get then from the body the set linear velocity. And there, so we have that. And there we set the x value to our move component current speed multiplied by the move component direction value. And that's it, right? So when it has a move component, we set the linear velocity to that value. So that would be very simple. Let's see if we have a working player movement. We don't have a working player movement. Houston, we have a problem. I think what is the problem? It seems like nothing is actually happening. That's interesting. Let's debug it. Do we end up in this method here? Wait, here. Then do we end up in the move system somewhere? And finally, do we end up in the physics system? Okay. So we for sure getting inside the move system. And currently we have none direction, which says that we do nothing. Okay, so let's move on. I forgot to set the move system breakpoint. I want to have another breakpoint in here. Okay, also the physics system, we get inside that method here. So setting the linear velocity. I could imagine that this is also working already. So the only thing that we are missing now is what happens if I press D. We set the move X to 1. We get a move direction of to right, which throws us in here. We have current of 0. So this is false. IntelliJ already tells us this. Our current is 0, so we are not here. We have a timer. We calculate here the current, which is a value between 0 and maximum, and the timer is already 1 because of the debugging, not sure. So immediately we would have a current of 3. So in our move component, we have a current value of 3. Okay, what happened? Okay, I need to stop here the breakpoint because otherwise we cannot move at all. But why is he not moving? So with debugging, we cannot find out what is the issue here. So let's make here a print statement. Maybe that one is not working. Maybe I need to call set linear velocity instead of applying the X value here directly. Maybe that is an issue. No, it's always 0. That's super interesting. Either when it should be 3. Why? We need more debug information. So what we need is current equals move component current. Then we have direction, which is move component direction. And finally we have lin, which is from our body, the linear velocity. Okay. Now I press D. So we have current of 3, direction to the right, but the linear velocity is not updated. Aha! So that's the problem. Then let's try this other method that we have seen, set linear velocity. And there we pass in this value for X and body linear, and whatever is the Y value, we keep it. We don't want to change that. Is that one now working? Yes! Oh yeah! Left movement is not working. Who cares? We can move to the right. We don't need more than that. People who are going left are anyway falling behind. Wow, okay, that's cool. It feels rather bad. I think we should, the acceleration at the beginning should be a little bit faster. Also, it looks stupid because we don't have an animation yet, but we will fix that later on. And I think the player can be a little bit faster. So 3, let's fine tune a little bit, but don't waste too much time on that. I think 5 is good, and also it should be a little bit faster. Maybe after 2 seconds, we should be already at maximum. Let's see. Yeah, that feels a little bit better. So that's working. Cool. So we fixed that already, and I didn't know that you can directly set the linear velocity and that it's working. I always thought that's not working. Just to be 100% sure, we will make a little test. We add here tile, because that should block our movement. Let's see if it does that. Or if we bypass now the physics simulation. No, so we really get blocked here, which is cool. Which is way easier than I did it in the past. And there is no downside to it. So first of all, let me share the link here if people are interested. So this iForce 2D is the, I think, official documentation, or at least a very good documentation about Box 2D. And he's really doing that. Forces are more suited to the gradual acceleration to top speed scenario. So let's try that first. This is similar to the above in that the acceleration is linear and the braking is non-linear. For this example, we have a pretty basic logic. So he's applying the force instead of setting the linear velocity directly. Okay. Yeah, but you cannot have like instantaneous speed change. So let's say the top approach, from what I understood from quickly reading it, that's the unrealistic approach and not how physics works in the real world. And this is exactly what we want, because a platformer does not have or should not have a very realistic physics scenario. We just want to have whatever we do. And when we can really set the speed directly, that's already great and good enough. So there's updating here. All of that is not working yet. But actually, why is it not working? We apply here current and we multiply it with the direction, which makes it positive or negative. But why are we not accelerating to the left? That one I did not understand, because we move super slowly. And let's think that through. Our current is... because of that one. We reset it all the time. Yeah, I get it. So that check does not work. So we would need to detect when the direction is changed and then reset those values. I think the easiest thing is actually, we don't do that in the system. So my idea would be that we have a setter in the move component. So when the direction gets set and it's right, and now we set it to left, or it's left and we set it to right, then we set those values to 0. However, I think a more natural one, and this is also how it is in most platformer games, you don't stop immediately and immediately go the other direction. Normally there's a few frames where you decelerate very fast, and then you just go to the left. And that one we could not implement in the component setter, because there's just a one-time thing that we set something and that's it. So I am more thinking now that we somehow fix it in here. So instead of multiplying here with the direction, for now, let's remove that. So let's imagine somehow we need to fix that the current move speed has here a correct value. If we want to go left, we go left. And if it's right, we go right. Can we achieve that? Are we smart enough to achieve this? So here, when we apply the interpolation, what would happen if we multiply here by that direction? So first of all, that one I can remove because that's really a useless assignment. Does that help us? So we would imagine again the scenario. We go to the right And then we switch direction to the left. So we would go to the right, that's this one. And we want to move to the left. So the timer starts again from 0, gets updated here. And we will be at a speed of 0 something. And because we multiply it, not we add it, we multiply it by the value. So the current becomes negative, which we set here. Physics system is correctly setting a negative velocity. Next frame, we come in here again. Here we now have a negative speed, which would be that case. And we are moving to the left. So interpolation is calculating a new value, which is positive. Then we make it here negative again. That should, in theory, work. Let's see. So let's go to the right. Let's go to the left. Yeah, that's working. Actually, it feels already a little bit like we are not actually moving to the right when we press the left button. But since we slowly accelerate backwards, at least for me, that feels already quite good. Also, I tried it out now. So we go to the right and press the left key, then we stop. If I release the right key, we go left. If I release the left key, we go right. So that also seems to work. So if you would press both buttons at the same time, that's also working. Yeah, actually, that feels already quite good. So that one we can remove. And also I want to zoom out a little bit because the character is big. So for me, it feels like we are way much, too much zoomed in. Normally, a lot of devices have a 16:9 aspect ratio. Some phones have 21:9 or 19:9. That might be too big, but let's see. No, I think that's quite good. We can live with that. What's also a little bit weird, as you see here, we would slowly fall down the gap. So there is a fix, I think, which is maybe the circle is bad here for that one. So it's weird that we can somehow climb back. But those are all small things that we can then fix. I think the movement itself is good. What I still think that we should be faster, to be honest. Way faster. And also I will remove now the garbage fixtures or the testing fixtures of the player. They also don't make sense and are causing some weird physics behaviors a little bit with jumping, because this fixture here is always going inside the ground. So let's have it like this, which is really cool. Let's be honest, that we just removed something in tiled and now this entire body is completely different. That is really cool. So I like it. Still, I think, or it feels like the maximum move speed should be higher. Maybe, I don't know, 8. Let's see how that feels. Yeah, I think that speed would be okay, but it should take more time to reach it. So maybe 3.5 seconds. Yeah, maybe even a little bit more, maybe 4.5 seconds to reach really the maximum speed. Yeah, that one I would say. That feels okay-ish, so I like it. So moving slowly around like this, that's okay. Also, we get to a higher speed rather quickly because of this power 5 out interpolation that we use. So I like it. So I think for a first movement in our game, that's more than good enough. So this line we can simply remove. Entity wants to move right or left. And here we also make a comment. Entity wants to change direction. Reset timer to start from slow. Move speed again. That's what we did. Yes, so here, let's call it just movement, but that's done. And I would say with that one, we actually reached the goal of today. And tomorrow, we will then implement some jumping, which most likely we will then also do with setting the velocity directly. So the Y value in that case, I think that's a lot easier to implement and to use. I like it that we found that out, that it's working like that. That's really cool stuff. So let's quickly go over the things that we have changed. Is there still some debug code or anything in it? So we have the move system. We have a keyboard processor in our game screen. We add that keyboard processor and we remove it. We remove the debug stuff in here. Oh, and there I remember something now. Haha, that we forgot. Remember when I told you that sometimes you have very huge delta times and that's not good for your game because most likely you cannot handle a delta time of 5 seconds or whatever. And we can very easily solve that. That's also a solution in some things. Like in stage, scene 2D, for example, they kept the delta time with a specific maximum value, which is allowed. And we will do the same. So we take over this code here and paste it here. Clear screen. We always want to clear the screen. So we want to have something like this. This is why, by the way, why we have a black background color. So we could, if we change that to red, then our background color would be red. Which actually let me... No, that hurts the eye too much. I think it's not good for the stream. But anyway, in here, we want to get that value. And at most, we want to have a value of a quarter second. So that's how we avoid very huge delta times. It's a very easy fix, maybe not the best one, but it's a good one. So for example, if you have a super slow device which cannot handle the game properly, and most likely if it would still try to run the game as fast as possible, it will simply become slower and slower and slower. And at some point you just have like, I don't know, one image every 3 seconds and so on. And things are just teleporting around. And with that little fix here, the player still sees maybe not 4 pictures per second, but even if it takes him like 2 seconds to get one image, everything in our game just moves by a quarter second. So it's not teleporting around a lot. It's still something which can be handled from a player point of view. So that's a small fix to handle huge delta times. Okay, then we had our keyboard input processor, which is also quite simple. So tomorrow we will add here another button, for example, the space button, and then we want to jump. We had the move component with the move direction, which was good. We have the move system, that's also fine. Then in the physics system, what did we do? We applied now this... Actually, it's not a move impulse. It's update linear velocity of entity, or update linear if entity has a move component and this moving is also wrong, because if the entity is not moving, so it has a move speed of 0, we also want to update the linear velocity. So that's also good. Then in here we fixed now, first of all, we had the input process and this extension value, because we are always working with a multiplexer, which is also fine. And finally, the spawn system, where we added the move component to our player. And I think that's it. So in general, this configuration stuff here, like move speed and so on, we most likely won't keep it here inside the spawn system. At some point, we will extract it to a configuration class or even to a file outside, which might make sense. But yeah, let's see. And everything else, that's it. Those are just the graphics. Okay, implement basic move behavior. Good stuff, good stuff, good stuff. So we are done with day 3.1. So again, tomorrow there will be another stream. I'm helping my parents because they are moving to a new house. And in the afternoon, I'm helping them. But later in the afternoon, maybe, I don't know, maybe same time as today. So 4 or 5 in the afternoon, Central European time, I will make another stream. And tomorrow we will then implement the jumping stuff. We will maybe write it, or we will write a test for the move system, just a simple one, and also make a GitHub action to automatically compile and test the code that we don't break anything in the future. I think that's a good point in time to implement that. Some other things that I noticed today, but we won't fix them tomorrow, is that one here. So what I noticed today is stop player from slowly falling down an edge. So there maybe either increase the mass, but I think that won't help, or set, is it called restitution in English? Not sure, but there are certain values that you can set in box 2D, or replace circle shape or feet with a box as well. It's not really a box, but it would be then more like the corner things again, which might be better. Also jumping here, we will make here the input controls, but you will be able to jump all the time. So most likely here we need to add implement put sensor to know if player can really jump. But that's something for that day, most likely. So here we will play a little bit around with the physics before we implement those two features. I could imagine that all of that is already one day. What is on day 5? Oh, that was the enemies. So day 4 for sure will be again 2 days. So those two features here, I can already imagine they will be part of a next day. So anyway, tomorrow, basic jumping and some GitHub optimization, which might be interesting for a few of you out there. And after that, we have then some animation that we have really a run animation, jump and fall animation, a sensor that we can detect when you can jump. So for example, let me quickly run the game once more. So here, of course, you would be allowed to jump because we are actually on the ground. When you are here, you can still jump most likely, but when you fall down, like here, when you're falling, you should not be allowed to jump. So this is what we will solve most likely with a sensor. Also, what we are missing, and I just noticed that, but that's a simple one. Let's do that here. Camera system to follow player. that helps us then so that we can also make then the map a little bit bigger, that we can move around, because currently our playground to test the movement and jumping is very small, so we can increase that. Good, but that's it for today. Thanks for watching again, and have a nice rest of the evening, and hopefully see you tomorrow. Bye bye.